So again, let's have a particle in a one-dimensional prison between x equals 0 and x equals L. And let's think about ways to increase the energy. How can we increase the energy or the energies? We know that we're going to get a range of energies, a discrete range, a discrete spectrum of energy. So let's first derive that again. So we know that the wave function looks like sine kx when we solve the Schrodinger equation, and has to vanish. We choose the sine because it has to vanish here, and that has to vanish here, and here's where we get the condition on the energies. So KL has to equal to n pi, such that the whole thing vanishes at this point as well. And so K is equal to n pi over the length of the well. How do we get the energies? Well, the momentum is h bar k, and kinetic energy is p squared over 2m. So E, it's going to be E as a function of n, right? That's the quantization of the energy. So its momentum actually becomes a function of n as well. And so we get, we square this, we get h bar squared, k squared over 2m. And now we can put in this value of k, so that's h bar squared over 2m times k squared, which is pi squared n squared over L squared. A little redundant here because we have the pi in here, and so let's get rid of the h bar. Let's write it in terms of h. So in terms of h, we get, so there's an n squared here, then we get an h squared. This is h squared over 2 pi squared, so that's 4 pi squared. So 4 and 2 gives us an 8, and the pi squared cancels with this pi squared. We have the mass 8mL squared. So those are the energy levels, and we can see that there are two ways of increasing the energy levels. Either we make the mass smaller, so we put an object in with smaller mass in the prison, so we don't change the length of the prison. It's still confined in the same region of space, but we lower the mass. That's a little counterintuitive. That'll give us higher values of energy. And then the other way is to shorten the well. So shorten the well or the prison, shorten the length, right? Make it smaller than L. So we're confining the particle more, and that's just the uncertainty principle, right? The smaller the range of positions, delta x, the larger the range of momentum, and therefore the larger the range of energies. Momentum and energy are related in that way. So those are the two ways in which we can increase the energy levels.